In this question, it is given that if 1 cube plus 2 cube plus 3 cube plus and so on up to n terms upon 1 into 3 plus 2 into 5 plus 3 into 7 up to n terms, the ratio is given to you as 9 by 5. Then the value of n is dash. You have to fill in the blank. First of all, numerator is clearly n into by 2 whole square. You must be knowing this formula. And denominator is equal to sigma, because if we look at first part, it is 1, 2, 3 and so on. Therefore, R sum will be R into. If we look at the second part, it is 3, 5, 7 and so on. That is, the numbers in second part are forming an AP with first term 3 and common difference 2. Therefore, the R term will be 3 plus R minus 1 into 2. That is 2R plus 1. Therefore, the R sum of second part will be 2R plus 1, and R will vary from 1 to n because it is given that there are n terms. Further, agreed, we can proceed in this way. Sigma R is equal to 1 to n 2 R square plus sigma R is equal to 1 to n R. Yes, we can proceed in this direction, but the way which I am going to tell you, that is better. The better way is in the sense that in the better way there is symmetry, and symmetry always makes the solution simpler. What I mean to say, suppose R into R plus 1, R is equal to 1 to n is given to you. Then the result is sure to be n into n plus 1 into n plus 2 by 3. Suppose R into R plus 1 into R plus 2 is given and R is equal to 1 to n. The result is n into n plus 1 into n plus 2 into n plus 3 by 4. That is, you can see very easily, every time I add one more extra term and divide by the total number of terms. Similarly, had it be R, R plus 1, R plus 2, R plus 3, then the result would have been n, n plus 1, n plus 2, n plus 3, n plus 4 by 5 would be there. And in the similar way, that is why R is equal to 1 to n, R is there, then it is n into n plus 1 by 2. Actually, you can see very easily, every time all the results are symmetrical, and symmetry always makes our calculation simple. That is why I will be using this direction rather than the previous direction which I was telling you. To proceed further using that direction, I can write it as R is equal to 1 to n R into 2R plus 2 minus 1. That is, R is equal to 1 to n 2 into R into R plus 1 minus sigma R is equal to 1 to n, simply R. Clearly, this is equal to 2 into n plus 1 into n plus 2 by 3, as I told you just now, minus n into n plus 1 by 2. Hence, we have found that the value of denominator in terms of n is this, and value of numerator in terms of n is this. And now putting the values of both numerator and denominator, I will get n into n plus 1 by 2 whole square upon 2 into n plus 1 into n plus 2 by 3 minus n into by 2. This is equal to 9 by 5. Further, I am going to take n into n plus 1 by 2 common from denominator and numerator, and that will get cancel, and remaining will be n into n plus 1 by 2 upon 4 into n plus 2 by 3 minus 1 equal to 9 by 5. They will get cancelled. That is, I conclude that 5 by 2 into n plus 1 is equal to 9 into 4n plus 8 minus 3 by 3. That is, I get 5n into n plus 1 is equal to 6 into 4n plus 5. That is 5n square minus 19n minus 30 equal to 0. Clearly, it is not convenient to solve this by using quadratic formula. But because it is given to you that n is a natural number, in such a case, mostly it is easier to solve it without using quadratic formula. See what I am going to do. Take constant term on right hand side. But note that this way is applicable only if n is given to us as natural number or integer. And now it is clear that I can take n common. 5n minus 19 is equal to, and you know that 30 is equal to 2 into 5 into 3. And from left hand side it is clear that we have to write this number as product of two numbers which are in the form of n into 5n minus 19. It's clear that if I take the value of n as 2, then the value of this, if it becomes, then the value of this should be 15. It is clear that by taking n equal to, this is not becoming 15. It's very easy to see that if I take the value of n as 5, this part becomes 6. Therefore, what I mean to say that write 30 as 5 into 6. It's clear that if I take the value of n as 5, 25 minus 19 is 6. That is, I have written right hand side in this form, and now it means I have got the value of n as 5. Note that I can't take the value of n as 6, because if I take the value of n as 6, this should become 5 for n equal to 6. Hence, we have got the value of n as 5. Some of you may be thinking that for every quadratic equation there are always two roots. Okay, we have found the one root by common sense. Where is the other root? I will say finding other root is absolutely not difficult, because for any quadratic equation, if one root is known to you, then you can easily find the other root by using the formula of sum of the root or with the help of product of the roots. If one root is known to you, you can easily find the other root. You can easily see that. Still, for more clarity, I am telling you clearly, product of the root is minus 6, and one root I have already found is 5. Then if the other root is alpha, 5 into alpha will be minus 6. That is, the other root will be minus 6 by 5, which is useless because n is a natural number. Hence the value of n we have got is 5. Hence the answer to this question is 5.